Now we're going to learn how to simplify radicals. We're going to learn that we can combine radicals. Now here, radical 5 times radical 7. So when we have multiplication, radical times a radical is going to give me a bigger radical. And I'm going to call this radical 35, square root of 35. Looking at example B, I'm going to call radical times a radical, give me the square root of 11p. The square root of 7 times the square root of 11xyz, that's going to give me the square root of 77xyz. So when we multiply radicals, we can multiply the numbers inside. If we have the same root, so we're keeping the root. So in this example, we're going to do the cube root of 36. Looking at example B, I have the fourth root of 24 yr squared. For example C, I have the sixth root of 50 m to the 5. Now looking at D, they have different roots, so I cannot just multiply them. In this case, let me write them as exponents. So I have 2 to the 1/4 times 2 to the 1/5. I know when they have the same base, I'm going to add the exponents. So let me rewrite 1/4. Let me multiply top and bottom by 5. So I have 5 over 20. On the second one, top and bottom by 4, that's going to give me 4 over 20. So this is 2 to the 9 over 20. We want to write it as a radical. That is the 20th root of 2 to the 9th. We can also split a radical. When it's a radical of a fraction, we can write this as a fraction of two radicals. Square root of 16 over square root of 25. Now, each of these are perfect squares. I know the square root of 16 is 4. The square root of 25 is 5. So that simplifies to 4 over 5. Same thing with example B. Let me write that as radical 7 or square root of 7 over square root of 36. We know 36 is a perfect square. So I'm going to write this as square root of 7 over 6. For example C, I have a negative. So I'm going to do that, the negative of the cube root of 8 over the cube root of 125. We know the cube root of 8 is 2. We know the cube root of 125 is 5. So I'm going to rewrite this as negative 2 over 5. We can have negatives inside the radical. Answer will be negative altogether as long as the root is an odd number. The root was 3, so yes, we can do this. For example D, I'm going to do the cube root of 7 over the cube root of 216. Now, I don't know what the cube root of 7 is, so I'm just going to leave that as cube root of 7. Now, the cube root of 216, that is 6. Simplify any radical if you can. The fifth root of x over the fifth root of 32. Now, the fifth root of 32, a number multiplied by itself 5 times to give us 32, we know that one. That happens to be 2. So I have the fifth root of x over 2. Here I have the negative of the cube root of m to the 6 over the cube root of 125. So it's a negative. The good thing with numbers, when the exponent is it's bigger than the root, sometimes the root cancels out. Now here I'm going to get m to the second. And the way I got the m to the second, I went the exponent divided by the root. Now at the bottom, the cube root of 125, that's just 5. Now we got to learn how to simplify. Square root of 24 is not a perfect square, but I can split this into two radicals, two square roots, one of them being a perfect square root. Now I'm going to call this square root of 4 times square root of 6. And the reason why, because square root of 4 is a perfect square, so I'm going to call this 2 radical 6. Square root of 6, I cannot split it into two radicals where one of them is a perfect square. I can split it into radical 2, radical 3, but none of them is a perfect square, so I cannot simplify this. Now, looking at this other one, 108, I'm like, well, I can split this as radical 9 times radical 12. I know radical 9 is 3, so this is 3 radical 12. Don't get confused thinking like, oh, I already took out a perfect square, I'm done. Because radical 12, I can still split it into two radicals. I can split this as radical 4, radical 3. Remember, I'm trying to split it into two radicals such that one of them is a perfect square. Now, radical 4 is 2. I can combine my whole numbers, 3 times 2. My answer will end up being 6 radical 3. Now, you might come and say, well, 108, couldn't have just split that as radical 36 times radical 3? Yeah, that way it will give you 6 radical 3. Whether we factor it in just one shot or factor it in steps, that's basically what we're going to do. Now, looking at C, radical 10, I cannot split it into two radicals such that one of them is a perfect square. So my simple form is radical 10. Now, in example D, I'm doing the cube root of 16. I'm going to split that as the cube root of 8 times the cube root of 2. I want to split it such that one of my roots is the perfect root. Now, cube root of 8, that's 2. So I'm going to call this 2 cube root of 2. With letters, I'm going to do the same thing. I'm going to split numbers and letters to begin with. Now I have radical 16 times radical m cubed. I know square root of 16 is a perfect square. Now my m to the third, let me factor it. Let me split it into two roots. I'm going to take out the biggest even number that I can. So I have this as the square root of m squared times the square root of m. That's the square root of m to the third. So once again, square root of 16 is 4. The good thing is that the square root of m squared is just m. Because if we think the root is 2, exponent divided by root gives me m to the 1. And then radical m. Looking at example B, I'm looking at this as the square root of 200 times the square root of k to the 7th times the square root of q to the 8th. Now, square root of 200, I'm going to think of that as square root of 100 times square root of 2. Because square root of 100 is 10. K to the 7th, I'm thinking that as k to the 6th and k. Because the square root of k to the 6th is k to the 3rd. Now, q to the 8 is already an even number. The square root of q to the 8 is q to the 4th. Exponent divided by root. So I'm going to have 10k to the 3rd, q to the 4th. Inside my radical, I have 2k.